Hello, welcome to this video presentation of the final project for CNT3122, Sensors for IoT. We are Boris Navarro and Carlos Carros. Our product is a smart parking system. To begin with, I would like to go over what made this idea possible, and just the overall brainstorming process. So we all know that the parking situation at FIU is rather problematic. Happens to all students. They come in 20 minutes early for class and they must check floor by floor, lot by lot, until they find an available spot to park. This increases tardiness to class, this increases the traffic going into and within campus, and it just places a lot of stress to the students because they can't find their spot, they're going to be late to class, they're going to miss something important, and it's just not a pleasant situation to be in. Benefits of having a smart parking system may include an optimization of the parking utilization, a reduction on the carbon emission by cars that are circling around for an available parking spot, and just an overall improved experience. That being said, our goal was pretty straightforward: to create a functional smart parking system. Most parking systems, most rather smart parking systems, operate by integrating several key components to provide real-time information and optimize parking operations. They typically use sensors and detectors, which can be ground sensors such as ultrasonic sensors, infrared sensors, radar, or even overhead cameras with image recognition. In our case, we went with IR sensors. They detect the presence of vehicles and monitor parking space availability. In order to make this idea a reality, we got a hold of the following components. We have an Arduino UNO R3, which is the brain of the operation. It's going to be used to receive and send signals to every other component found in this project. We have also a breadboard that we're going to use to connect everything together, to distribute power, and so on. We have prototyping wires for connectivity and testing. We have a 10K potentiometer, which is going to be used in conjunction with a LCD screen. So the 10K potentiometer is going to be used to basically change the brightness of the LCD screen. Now that I mentioned that, that's another component that we're going to be using. Just one 16 by 2 LCD screen, no I2C connection. We have one servo motor that's going to work as a gate entrance, and then we have 6 infrared obstacle avoiding sensors. These are going to be 2 for the entrance and then 4 for the parking spots, one for each parking spot. And the things will be connected as follows. On this KiCad schematic, we can see all the connections going on. So at the very top, what we see is the LCD screen, and then on the right side we have a 10K potentiometer at the top, and then the bottom 4 components are 4 IR sensors. Right across those IR sensors we have the Arduino UNO R3, and on the bottom section of the schematic we can see 2 IR sensors and the servo motor. If you look close, you can see that every single component is labeled. You might want to take a look to the IR sensors specifically. The top one on the right side is going to be for the spot labeled as floor 1, spot 1. The one immediately below that one is going to be floor 1, spot 2. After that, we have floor 2, spot 1. And then lastly, we have floor 2, spot 2. On the bottom side, on the right hand side, we have the 5th IR sensor that's going to be working as an entrance sensor. So if we have a car coming in, it's going to check with that sensor. If we have available spots, it's going to make a call to the servo motor so it opens the gate. And then to exit the parking lot, we have the exit IR sensor, which is the 6th IR sensor. This one is inside the parking lot and it's gonna simply allow every single car to exit. Now, regarding the connections, we have the LCD screen at the top that has the connection RS to the digital pin 7, E to digital pin 6, D4 to digital pin 5, D5 to digital pin 4, D6 to digital pin 3, D7 to digital pin 2, BSS to ground, VDD to ground, BO to the potentiometer's middle pin, RW to ground, and then we have A to the Arduino as the 5 volts, and then K to ground. Then we have the potentiometer. One side connects to the 5 volts, the other one connects to ground, and then the middle pin connects to the VO. We have the servo motor that has the VCC connecting to power, which is the 5 volts, ground connecting to ground, and then we have basically the signal, which is connected to digital pin 9. After that, we have the following sensors, IR sensors. They're all going to have connections to VCC 5 volts, ground to ground, and then the sensor out is going to be the output of the said sensor, and it's going to go as follows. Spot 1 from floor 1 is going to be pin 8. Spot 2 from floor 1 is going to be pin 10. Spot 1 from floor 2 is going to be pin 11, and spot 2 from floor 2 is going to be pin 12. We use spots 1, 2, 3, 4 and 1, 2, 1, 2 interchangeably along this presentation, okay? Lastly, we have the entrance sensor, which is going to be pin A0. We're using the analog pin as a digital pin, and then the exit sensor is going to be pin A1, again using an analog pin as a digital pin. And this is the same as the previous schematic, just as a diagram instead. Connections are the same, it is just a more visual representation which makes it easier to follow in case that the viewer wants to give a try to this project and test their Arduino skills.
And now on to our code. I'm going to focus on the highlights of this code. In the first part, I'm focusing on the hardware components, since we're going to be using an LCD screen, an LCD display. We need to instantiate it with a liquid crystal LCD and then the pins associated with that. Also the servo motor, we're going to call it gate servo, and the various IR sensors that we'll be using for detecting the cars. We're going to assign the pins in the Arduino. Since the Arduino UNO is very limited in terms of pins, we're going to have to use the analog pin 0 and analog pin 1 for the entrance sensors. Up next is the parking space management. We initialize the variables spot 1 occupied, 2, 3, 4, occupied as Boolean variables, and we assign them as false, so start as not occupied. The second part is the available spots in the entire, per floor and the total ones, which is the sum of both total of available in floor 1 and available in floor 2. Now we have the sensor readings. This constantly monitors all sensors. That belongs to the loop function, or the loop function. It reads each and every one of the sensors, including the entrance and exit sensors, and then sends a signal to the display and updates the display later on when you see the function. Here is the gate control logic. This gate control system um, has two main parts. The first one is the decision-making logic that determines when to open the gate, and the automated operation that handles closing it safely. Let me explain it now. So the first part is for entering. It detects the car is detected at the entrance. The gate is currently closed, so the system isn't waiting for a car to clear the exit. If these conditions are met, it then checks if any parking spots are available. If the spots are available, it opens the gate and starts a timer. If the parking is full, it keeps the gate closed. For exiting cars, which is the second part of the code, um, when the car is detected at the exit and the gate is closed, the system opens the gate and sets a flag, which is waiting for exit clear, to track what we're waiting for the car to pass through completely. So that way it is a safe way to um, enter or exit the garage. Now, how does the gate operate automatically? Well, it has two mechanisms for closing the gate. When a car enters the gate stays open for a fixed duration, which is the function gate underscore open underscore duration, which is set to 5 seconds. This allows enough time for the car to pass through before the gate automatically closes. And the second part, um, it is sensor based. So for exiting cars, the system waits until the exit sensor no longer detects the car, meaning the car has completely passed through, and then closes the gate and resets the exit flag. So this approach is like the cars entering have a reasonable time window to pass through. Cars exiting trigger the gate to close only after they have fully passed through. The gate remains secure when not in active use. So, and now we have come to the last part of the code, which is the loop function that uses all the functions that I mentioned before, reading the spot sensors first, then updating for availability, displaying it on the LCD, and then managing the logic gate. Then 100 milliseconds, which is a short delay to prevent excessive processing, and then it keeps going back. I think this is pretty much the highlights of our code, and let's move on to the other part, to the next part. As you can see, the display shows that there are 2 spots available on each floor for a total of 4. We have the second floor with the sensor on each spot, the first floor again with the sensor on each spot. We have the servo motor with a sensor on each side to check the detection of cars. Now when it approaches, it detects, and then it checks, the second one checks that the other one has cleared. Now once the car is parked, the sensor detects the presence of the car, and then it updates floor number 1 with only 1 spot available. The process continues, and then this one decides to go to the second floor, and now there's only 1 spot available on each floor for a total of 2. Next one is allowed in and finds a spot on the second floor. Now there are no spots available on the second floor and 1 remaining on the first floor for a total of 1 in total. Comes our last car. Same thing. Hopefully it fits there in this parking spot. Detects it. Now parking full. There's no availability. What happens if another car wants to come in? Well, let's try it. Let's use this one. It says parking full. If you look at the sensor, the sensor is detecting the presence, but it's not allowing any car in. Then when a car leaves, it is up, the display is updated, and then the other car can come in, but only one car, and then it is placed in this spot, and again, the parking is full. Summing up, we have successfully created a smart parking system that optimizes parking by substantially reducing the time to find an available spot by using the LCD screen in front of the garage. It can accurately measure number of empty spots and their locations for easy access. For future implementations, we recommend including a system of RGB LEDs that aids when traversing through the parking spots by highlighting them in red for taken or green for available. Um, it would also be nice if we could have a dashboard that helps in finding parking spots ahead of time before we actually head for the parking garage. Designing an admin dashboard for parking management and data analysis would be great. In that way, we know, or management, the administration would know um, the most critical uh, times of the day, the most critical days of the week, and the most critical days of the month. Also, like soldering components together and improving cable management, creating PCB board to like minimize um, the size of the implementation would also be very beneficial. For our project, we use these 5 references, which really helped a lot in understanding the concept of smart parking solutions. Um, and with this, we conclude our presentations. We thank you very much for your attention, and until next time.